Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method, part 2. So let's get going. Solve y double dash plus 4y equal to 4 tan 2x or d square plus 4 into y equal to 4 tan 2x. So this is an operator form of the first equation. Okay, both equations are same using variation of parameters method. So we are going to solve the given differential equation in another way by using variation of parameters method. Okay, fine. We are given a differential equation of order 2. Given differential equation, y double dash plus 4y equal to 4 tan 2x, considered as equation 1, or we can write y double dash as d square y by dx square plus 4y equal to 4 tan 2x. We can write d square y by d square dx square as capital D square y, since capital D is an differential operator, right? D square is a differential operator, so we can write d square y by dx square as d square y, since d equals to d by dx, then d square gives d square by dx square plus 4y equal to 4 tan 2x. Now take y common from the two terms of LHS, we'll get d square plus 4 into y equal to 4 tan 2x, which is an operator form, say f of d into y equals to some function of x, where f of d equal to d square plus 4 and r of x equals to 4 tan 2x. Now consider this equation as equation number 2. The homogeneous form of equation 2 is d square plus 4 into y equal to 0. Consider it as equation 3. Now we'll find the solution of homogeneous equation using auxiliary equation, and using that solution we'll write the solution of equation 2 or equation 1 just by changing the parameters with functions of x, right? So let's begin with auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 4, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square plus 4. Now the auxiliary equation becomes m square plus 4 equals to 0. Now we need to find roots to this equation. This gives m square equals to minus 4. Then m equals to plus or minus square root of minus 4. We can write square root of minus 4 as minus 1 into 4. Now we can split the square root of minus 1 into 4 as square root of minus 1 into square root of 4. Since square root of minus 1 is I and square root of 4 is 2, so we'll get plus or minus I into 2 or plus or minus 2I. Therefore m equal to plus or minus 2I. The roots are complex conjugate. We know that when m equal to a plus or minus ib, that is a pair of complex conjugate roots, then the solution of homogeneous equation looks like y equal to e power ax into some constant, say c3, cos bx plus another constant c4 sin bx. Here I am taking c3, c4 instead of c1 and c2 because in the last general solution I need c1 and c2 to appear. Okay, So I'm using C3, C4 instead of C1 and C2. So in case of A0, we'll get e power 0 into x, which is e power 0 of C3 cos bx plus C4 sin bx. And e power 0 is 1. So this gives 1 into C3 cos bx plus C4 sin bx which gives C3 cos bx plus C4 sin bx. Let's now write our homogeneous equation, solution to our homogeneous equation. Just compare plus or minus 2i with plus or minus ib, then for b equal to 2, we'll get the solution to homogeneous equation equation 3 is y equal to c3 cos, for b equals to 2, we'll have 2x plus c4 sin 2x. Now using this solution, we'll write the general solution of equation 1 or equation 2 because 1 and 2 are same equations. Let y equal to, let us replace the constants or parameters with functions of x, a and b, then we'll get y equals to a cos 2x plus b sin 2x. Be the general solution of one or two, okay, where a and b are functions of x, right? Now just compare the solution to homogeneous equation with y equals to some c3u plus c4v, or the solution, general solution with y equals to some au plus bv. We'll get u and v, where u is cos 2x and v is sin 2x, right? Here u is cos 2x and v is sin 2x, and we'll find a, b using formula a dash equals to minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus vu1. So if you notice, we are having uv1 minus vu1 in both the formula, right? So here we need to find, first thing, uv1 minus vu1, and second thing we'll find a dash, third we'll find b dash, fourth we'll find a, fifth we'll find b, and finally we'll get the general solution by substituting a and b. So let's begin with the first thing, uv1 minus vu1. Here v1 is nothing but derivative of v with respect to x, and u1 is nothing but derivative of u, or you can write it as d by dx of v for v1 minus v into u1, or u dash is nothing but derivative of u with respect to x. This equals to u cos 2x into derivative of v with respect to x. V is sin 2x minus v sin 2x into derivative of u cos 2x with respect to x. This gives cos 2x into derivative of sin 2x with respect to x is 2 cos 2x minus sin 2x into derivative of cos 2x with respect to x is minus 2 sine 2x. Right? This gives 2 into cos 2x into cos 2x is cos square 2x, minus into minus plus 2 into sine 2x into sine 2x is sine square 2x, or we can write it as 2 sine square 2x plus 2 cos square 2x. Now take 2 common from these two terms, we'll get 2 times sine square 2x plus cos square 2x. Since we know that sine square theta plus cos square theta equal to 1, right? So now we'll apply here. We'll apply this formula or this identity here. We'll get 2 times 1, which is equals to 2. Therefore, uv1 minus vu1 equals to 2. Now let's find a dash. A dash is given by minus v into r of x by uv1 minus v1. This equals to minus v sine 2x into r of x is 4tan2x by uv1 minus v1, which is 2. This is equals to minus 1 by 2 or minus 4 by 2 into sine 2x into tan 2x. This gives minus 2 sine 2x into, since tan theta equals to sine theta by cos theta, so we can write tan 2x as sine 2x by cos 2x. This is equals to minus 2 sine 2x into sine 2x is sine square 2x by cos 2x. Since we know that sine square theta plus cos square theta equals to 1, from this we'll get sine square theta equal to 1 minus cos square theta. So let's replace sine square 2x with 1 minus cos square 2x, since if we replace theta by 2x, we'll get sine square 2x equals to 1 minus cos square 2x. Right, then the numerator becomes minus 2 times minus cos square 2x by cos 2x. If you notice, we are having 2 terms in the numerator and 1 term in the denominator, so we can split the total expression into 2 terms. We'll get minus 2 times 1 by cos 2x minus cos square 2x by cos 2x. Right? Since reciprocal of cos theta is secant theta, so we'll get a dash equals to minus 2 times reciprocal of cos 2x is secant 2x minus, if 1 cos 2x gets cancelled from the numerator and the denominator, we'll get just cos 2x, or this is equals to minus 2 secant 2x minus into minus plus 2 cos 2x. Therefore, a dash equals to minus 2 secant 2x plus 2 cos 2x. Let's now find b dash. We can find b dash using u into r of x by uv1 minus v1. Right? B dash is nothing but, just write b dash. B dash equals to u cos 2x into r 4tan2x by uv1 minus v1 is 2. This equals to 4 by 2 into cos 2x into tan 2x, since tan theta equals to sine theta by cos theta, and this gives 2 cos 2x into, we can write tan 2x as sine 2x by cos 2x. Your cos 2x gets cancelled and we'll get b dash equals to 2 2 sine 2x. Therefore, b dash equals to 2 sine 2x. Let's now find a using a dash and b using b dash. We have a dash equals to minus 2 secant 2x. So we can find a directly after finding a dash and b directly after finding b dash, okay? Here a dash is nothing but dA, derivative of a with respect to x. Since a is a function of x, this is equals to minus 2 secant 2x plus 2 cos 2x. Now we need to separate the variables, so we'll take the differential dx to RHS, then we'll get minus 2 secant 2x, that is differential dA equals to minus 2 secant 2x plus 2 cos 2x into differential dx. Or we can write it as dA equal to minus 2 secant 2x dx plus 2 cos 2x dx. Right? Here the variables are separable. So we can perform integration. Integral dA equal to minus 2 integral secant 2x dx plus 2 integral cos 2x dx. Since we know that integral secant a theta d theta equal to 1 by a log mod tan a theta plus secant a theta, and integral cos a theta d theta equal to 1 by a sine a theta. Right? Now let's apply this formula here. We'll get integral dA a equal to minus 2 into, just compare secant 2x with secant ax, then for a equal to 2 we'll have 1 by 2 log mod, and for theta equals to x or x equals to theta, right? For x equals to theta we'll have log mod tan a theta plus secant a theta plus 2 into, now compare cos 2x with cos ax, then for a equals to 2 and theta equals to x, we'll have integral cos 2x dx is 1 by 2 sine 2x plus integral constant says c1. We cancel 2. So from this we'll get a equal to minus log mod tan 2x plus secant 2x plus sine 2x plus c1. Therefore a equal to minus log mod tan 2x plus secant 2x plus sine 2x plus c1. Now we need to find b using b dash. We have b dash equals to 2 sine 2x, right? B dash is nothing but derivative of b with respect to x, since b is a function of x, equals to 2 sine 2x. Now we need to separate the variables, so we'll take the differential dx to RHS, then we'll get differential db equals to 2 sine 2x into dx. Here the variables are separable, so we can perform integration. Integral db equal to 2 integral sine 2x dx. Since we know that integral sine a theta d theta equal to minus 1 by a cos a theta, right? Now this becomes integral dB equal to 2 into, let's just compare sine 2x with sine a theta. For a equal to 2 and theta equals to x, we'll have 2, integral sine 2x dx is minus 1 by 2 cos 2x plus integral constant says c2. Here 2 gets cancelled, and from this we'll get b equal to minus cos 2x minus cos 2x plus c2. Therefore, b equal to minus cos 2x plus c2. So we got a and b. Now we can write general solution by substituting a and b in this equation. Therefore, the general solution is given by y equal to a cos 2x plus b sin 2x. Let's now substitute a and b here. We have a minus log mod tan 2x plus secant 2x plus sin 2x plus c1 into cos 2x plus b minus cos 2x plus c2 into sin 2x. This becomes minus cos 2x into log mod tan 2x plus secant 2x plus sin 2x into cos 2x plus c1 cos 2x plus into minus cos 2x into sin 2x is sin 2x into cos 2x plus c2 sin 2x. So here minus sin 2x cos 2x and plus sin 2x cos 2x gets cancelled and we'll get y equal to c1 cos 2x plus c2 sin 2x minus cos 2x log mod tan 2x plus secant 2x. This completes the problem. So we have seen one way of solving a differential equation using variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.